Hello and welcome everybody to the stand from MyPV. Hot water from photovoltaics is our claim. We are a young Austrian company, so we are not a German company. We are guests here at the fair from abroad. And who of you is already familiar to the issue hot water from photovoltaics? Has anyone heard about it?
We in South America we can use photovoltaics for the showers. We have
directly. Okay, perfect. I came from the field of research from solar heat systems. I developed flat plate collector systems in the past, and when I heard about this idea, let's say 7 years ago, I was scared because PV power is so expensive and so valuable. It was not imaginable to use it for heat production. But what happened the last year is a great decrease of the PV costs, and this steady decrease of the PV costs has made it possible to think about applications like power to heat. And we started with hot water from photovoltaics 4 years ago. We have developed our first product, which is the ELVA. ELVA means electric water device. And the gray one, there's a model over there, is a pure DC product. You can connect a PV module string directly to the heater, 4 to 8 modules. It has an MPP tracker integrated and a linear power control unit from 0 to 2000 watts. So this is our main know-how at MyPV. We are an electronics company, and we can reproduce these power controllers, linear power controllers. There was the DC element, which basically does the same as a solar heat system. We use all of the power from the sun for heat production, but with cables instead of pipes. We do it many times easier and nowadays also cheaper. In Europe, it's very common to use the excessive amount in a grid-connected system, which is another approach. There is a PV system on the roof and an inverter. This system provides the electric loads of the building first, so the devices in your house, the light and so on. And usually the rest of the energy is sent to the power grid. Very popular is to add a battery, but usually this is a huge step of the investment costs. So this can be a cheap alternative. We use just the excess power, the power that is usually sent to the power grid for hot water heating. And therefore we have our integrated ELVA products. They have the immersion heater, which is inside of the hot water boiler or the storage tank, integrated in the device. And with a 1.5 inch connection thread here, we are compatible to the most common tank manufacturers, because this is a standard thread here. We have linear power control from 0 to 2 watts with a 1 DC solution that we have, and we have linear power control from 0 to 3000 watts with all our AC products. Now we have the situation that in the house of the customer, the final customer, sometimes there is an immersion heater already existing, and then we have to use this heater, and that is why we have developed our new product, which is the Actor. It is also an AC power controller. So this is not a smart home system or something like that. It's an AC power controller for linear power control of resistive loads. And these resistive loads, this can be also immersion heaters for hot water heating, but this can also be electric heating systems like electric heating mats in the floor, in the walls, or infrared panels, for example. So we are much more flexible on the kind of the load. And one of our principles at MyPV is that we have open communication interfaces. That means that we can receive the input signal of the excess power by another system, which can be an inverter manufacturer, can be a smart home system, can be a storage system. Because we do not compete with battery, we can be a cheap alternative, but we can also be a cheap way to expand existing storage capacities. And for example, with Vata and E3DC and however their names are, the battery is loaded first. Battery should have priority then, and after the battery is fully charged, we use the remaining excess power for heating. We can also meter this excessive amount on our own. For example, when no one of them is available, we have our own power meter, and the power meter gives our unit the information you need this and this level of power. And this happens very fast. You have to imagine clouds are moving on the sky, PV production changes every second, and also loads in your building are switched on and switched off. And this balance in the feed-in point has to be calculated again every second. And this is what we do. We avoid feed-in into the power grid, and we avoid import from the power grid. We have the linear power control to make the balance in the feed-in point. In this way, we increase the self-consumption ratio very high. So usually for a single family home in Europe, let's say a 4-person household, you have a self-consumption ratio of 30% or something. When you use the remaining excess energy for hot water heating, you can increase your self-consumption ratio to 75%, for example. So it's a huge increase at low investment compared to a battery. With the AC-THOR, we are much more flexible on the load. I already mentioned that. You can use an existing heating element, and yeah, we can also supply space heating, electric space heating concepts. We also have done a lot of projects on apartment buildings where we have done the photovoltaic water heating in the apartment. And as a manufacturer, we distribute our products via wholesalers or in the German-speaking countries also to the installers directly. We do not make any end customer business. Yeah, okay. A few minutes left. Can I answer some questions?
So you asked earlier about the system that we're familiar from where I come from. We're familiar more of the Ariston type of photovoltaic with the boilers.
It's a solar thermal system. Yes. So this is an important question. Thank you for asking. Compared to a solar heat system, we are times easier to install. We have just 2 small cables instead of pipes. So for a solar thermal system, you need a collector on the roof. You have the pipes into the basement from the roof. You have to insulate those pipes. You have a pump. You have valves. You have an expansion vessels. You need a control unit. You need cables for the sensors in the collectors and in the tank, heat exchangers and anti-freezing liquid, and so on and so on. And we replace all that stuff with 2 wires and an immersion heater that is able to do a linear power control. So in terms of installation effort, we are approximately 50% more efficient, and we are already cheaper because photovoltaics have become so cheap that we can compete with conventional solar heat systems in any way, in every way.
It seems these are resistive loads, like resistive coil. So how do you differentiate from the conventional resistive loads, those are water heaters, from this new technology? What is the increased efficiency with this system?
The special thing on our product is the capability to do the linear power control of the resistor. So a normal resistor is just on and off. Yeah, it has a certain level of power, and when you switch it on, you import power from the grid. Partially, you can use your own PV power, but this is not a smart solution because it has always the same level of power. Yeah, and our units can adapt to the PV power that is available. We can set 15 watts, and we can set 2,899 watts 1 second later. Yeah, so it changes with the solar power, and this is very important to make power to heat PV ready, because the energy source changes all the time, and you have to react on that.
So if I get it right, you don't have advantage for net metering, but for any other systems when you are overcharged for the energy.
Yes. In every case where self-consumption is interesting, this would be a solution. For example, in my country, in Austria, you nearly get nothing for feed-in, 4 cents or something, and then this is immediately interesting. Yes. For net metering, yeah, I cannot compete with the free system, of course. Yeah, when the meter is allowed to turn backside, it's not interesting to raise PV self-consumption, of course. Yeah, we have to be honest. It is like it is.
So any more questions? We have 1 minute left, so this is the chance. Yeah? No? No. Okay, then.
Thank you very much.